Hello. I wanted to take time and go over the questions that were the most missed on the test, so let's get started. For the first one, I see that this is an isosceles triangle, so I know that if these two legs are congruent, these two angles are congruent. I know all the angles in the triangle add up to 180. So if I do 180 minus 72, that'll be 108. Since there's two of them, I'm going to take 108 and divide by 2, and that would be 54 degrees. So this is 54, this is 54, KJL is this angle, so the answer would be 54 degrees. Now, the next one's kind of a continuation of that problem, so I'm going to go ahead and write the 54 degrees down here. And then if this is 54 degrees, then this angle is also 54 degrees because those are vertical angles, and we know vertical angles are congruent. This is also an isosceles triangle, so these two angles are congruent. So I know that, let's take 180, subtract 54. 180 minus 54 is 126. There's two of them, so 126 divided by 2 would be 63 degrees. So these angles are 63 degrees. So what is the measure of angle LNM? That's this angle right here. The answer is 63 degrees. All right, moving right along. All right, the next one was definitely interesting. Had a lot of triangles up in there. So I just went through, like, you got triangle CDF and triangle AJG. Those are right triangles, so I know that triangle CDF is congruent to triangle AJG, and that's because of hypotenuse leg. So that means all of their corresponding parts are congruent. So this angle is the same as this angle is equal to that angle, this side is the same as this side, and they've already got those marked, so we're good. All right, when I look at that, I can tell that DEF right here is congruent to JHG, so I can say triangle DEF is congruent to triangle JHG, and that would be by side angle side. So now we have, and if I go putting 5 dashed lines, it's going, well, I guess I'll try 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are congruent. That little piece, they've already got that marked. This angle is the same as this angle, and I know that these angles are the same as that angle because they're vertical angles. And then you can also say that triangle CED is congruent to triangle AHJ, and that's by side angle side. So CED is this one right here, and then AHJ. So that means all of their corresponding parts are congruent. So this angle here is congruent to this angle right here. And yeah, there's so much. There's triangle CBD is congruent to triangle ABJ, and that's by angle side. And remember, all their corresponding parts would be congruent, and triangle CBE would be congruent to triangle ABH, and that would be also by angle side. So when you have all these congruent triangles, that means a lot of these things turn out to be true. And this is true, this is true, and this is true. And you could go through and mark it up. And I mean, like, these are vertical angles. I mean, you got all sorts of stuff. And that's your angle side, angle side, angle side. All right. Let's look at the next one. It's not nearly as interesting. So look, you guys. This angle is the same as this angle, so that means this is an isosceles triangle. So this side is the same as this side, so this is 12. Well, if this is 60 and this is 60, I know this has to be 60 because they all add up to 180. Well, if all three angles are 60, it's equiangular, which means it is also equilateral. So if one side's 12, then this side's 12, and this side's 12. So when it asks me for the perimeter, all I got to do is 12 plus 12 plus 12 plus 9, or 3 times 12 plus 9, which is 36 plus 9, which is 45 units, because I don't know what it is. Oops, sorry about that. Okay. I guess I can mark all those congruent for fun. Yeah. Next. Alright, it says that these two bad mama jammas right here are parallel. They're also congruent. If these are parallel, then I know that this angle is going to be congruent to this angle, and I know that because they are alternate interior angles. Alternate interior angles. I also know that this angle is congruent to that angle because they're vertical angles. So they're asking me, how can I say that this triangle is congruent to this triangle? Well, oh, sorry, oh, my bad. They're asking how I can say this triangle is congruent to this triangle. ACD. CAB. I'm sorry, you guys. I'm having a moment, aren't I? All right, well, let's keep marking up then. All right, well, they share this side, so it's congruent to itself. And then you've got these other alternate interior angles. So I would say there's multiple reasons. I'm going to go with angle, angle, side. Right? Let's see here. ACD, CAB, angle, angle. Yeah, angle, angle, side. And then, okay. All right. All right, let's look at the next one. It says, oh wow, this one's got a lot of good stuff. So all right, these two sides are the same. It says this is 25 degrees, so 25 and 35 is 60. So that means that this has to be 120 degrees. So this is 60 degrees. So this has to be 30 degrees again, because they have to add up to 180, and that's a humongous symbol for a right angle. All right, these two are the same, so that means these angles are the same, so this has to be 60 degrees, which also means that this has to be 30 degrees, so this is an equilateral triangle. So if this little piece is 6 and this little piece is 6, so this means this angle is 120 degrees because, you know, they have to add up to 180, they make a straight line. And, all right, this triangle is going to be congruent to this triangle. They're both right triangles. They share a side. That's a leg. So we have hypotenuse leg. So I know that triangle MPT is congruent to triangle RPT, and that's by hypotenuse leg. So that means that the corresponding parts have to be congruent. So this side has to be the same as this side. So if this is 4, this is 4. The actual question is, what's the length from M to R? So 4 plus 6 is 10. So it'll be 10 plus 10, which is 20 units. All right, and then the last two. All right, it says, which theorem shows that QMP is congruent to RNP? So just what makes these two triangles congruent? They have vertical angles that are congruent. So that would be angle, angle, side. Angle, angle, side. All right, and this one a lot of people missed. It says, is it possible to form a triangle with side lengths 3.5, 3.5, and 9? So you guys think about if you've got one side of the triangle 9 units long, and then the other two pieces are 3.5. They're not going to be able to connect. These two should add up to a number bigger than 9, and they don't. They wouldn't be able to reach each other. It's like two little short arms or something. So No, you can't even make a triangle with that. So, all right, you guys, I hope you have a wonderful spring break and you're healthy. I miss you, and I will talk to you later.